So sine squared sine squared and cosine squared, I'm going to change it all to be in terms of sine, just like before. So same problem. I can skip some of these intermediate steps because we've already done them. It came out to be sine squared of x dx minus the integral of sine to the fourth x dx. Now, I'm going to use the sine squared of x, same one, minus, so it's 1/2 x, minus, now instead of 1/4, I'm going to go ahead and use the 1/2 sine of x cosine of x, because my reduction formulas are not in terms of the double angle, they're in terms of the sine of x cosine of x, and I want to be able to simplify more appropriately. So, that means I now have to go down to this minus, erase that, and deal with this sine to the fourth of x. So I'm going to use the reduction formula, which says, since, let me say n is equal to 4 in this first iteration, it's going to be minus 1/4 sine to the 3 of x cosine of x plus 3/4, the integral of sine squared of x dx. So right here, according to the formula, this is 1/n, since n is 4. This is n minus 1, which is 3. This is n minus 1, which is 3/n, which is 4. And this is n minus 2. And then this guy, I know. So this is now 1/2 x minus 1/2 sine of x cosine of x plus 1/4 sine to the third of x cosine of x minus 3/4. And we know sine of x, it's once again 1/2 x minus 1/2 sine of x cosine of x. So let's zoom out since I'm running out of space already. 1/2 x minus 1/2 sine of x cosine of x plus 1/4 sine to the third of x cosine of x minus 3/8 x plus 3/8 sine of x cosine of x. So it looks like I have 1/2 of x and 3/8 of x. So I'm going to call that 4/8 x. And so that leaves me with 1/8 x. Looking good so far. So then, because that 1/8 was in the previous answer. And so now I have 1/2, let's call it 4/8. Negative 4/8 plus 3/8 is minus 1/8 sine x cosine x plus 1/4 sine to the third of x cosine of x. Now you might notice that this answer, don't forget the plus c. I have a feeling I've forgotten the plus c, and I'm sure you've caught them. But with this one, you might notice that this doesn't look like my previous answer of 1/32 4x minus sine of 4x plus c. And this might concern you, but I sat down and I did the heroics that was necessary to determine that these two values, namely that this versus this, are equivalent statements. And they are. It took quite the extensive trigonometric identity hearty. It was not an easy one. I had to really sit down and think about it, and used a fair amount of algebra. But they are equivalent, and I debated on whether or not it was appropriate to bring this out for you, because I didn't know that you would need to see this. So what I'm going to do is I'm going to pause it, and I'm going to go ahead and write it out so I don't take a bunch of time in the video, so you don't have to fast forward, and then you can just come back to this if you want. So I'm going to pause it and write it on the next slide, and then it'll just appear. Okay, so here is the work for that identity, and I've proven that, and I made a mistake with a sign down at the bottom, and I wouldn't let me erase it when I realized it, so I left it and I just scratched it out. So I apologize for the messiness of it. You do not have to get it to look like this bottom answer. It is perfectly appropriate to leave your answer in terms of, you know, the reduction formula solution. So if you give me an answer like this, that's phenomenal. Now, I do want to mention that herein lies a significant problem with this, that being, you might have a different answer from your neighbor depending on if you do it the long way or you do it with reduction formula. So therein lies part of the issue. And your answer might look different from the textbook depending on what method the textbook used. So take this as it comes. You may need to do some trigonometric work to prove it to yourself, or you may just be like, you know what, I know I've got this reduction formula, or maybe check in with neighbors to see if they get the same answers when they're using the reduction formula, if it differs from the textbook. So unfortunately, that is part of the reality of using the reduction formula versus using the long methods, or vice versa. It just depends on how the textbook wants to answer that question. And the reason that is because you can see with this reduction formula, I end up with a sine cubed, and I have to go down to a quadruple angle. And it's completely based on the fact that trigonometry has identities. It's because sine and cosine are essentially the same graph with a phase shift. So with that in mind, we'll end up with equivalent but different looking answers. So globally, let's consider what we have to do or not do when we have these trigonometric integrals. Basically, if powers are all even. If powers are all even, then what you want to do is put entirely in terms of sine or cosine, depending on what you want to do. And after you put it entirely in terms of sine or cosine, you want to use reduction formulas. In this case, substitution isn't really possible, and that's kind of a bummer. So if powers are partially or totally odd. So this depends if there's both sine and cosine, or if there's only sine or cosine. If there's sine and cosine, it's totally illegible. Let me rewrite that nicer. If it's sine and cosine, then you can do a nice u substitution, and that's going to be your best way to do it, because you're not going to ever be able to get rid of one of them because one of them is odd. If it's only sine or cosine, doesn't matter if it's odd or even, you can use u sub or reduction formula. So if it's cosine to the 5th power, it's odd, you can use u sub if that's what you want to do, or you can go directly to the formula. But with a sine and cosine combination, you're going to have to rely on that u sub. So if it's evens, you got to put it all in terms of sine and cosine, and then use reduction formula. If it's odd, and there's a sine and cosine involved, then you can do u sub. If it's, or you must do because you're always going to have a leftover, or if it's partially odd, then you will have only sine or cosine. Then you can choose to use one of the methods to do the u substitution if you prefer, or you can go directly to the reduction formula. It's up to you. So what we haven't done much of today is we haven't talked about anything else but sine and cosine. So there's this other one that I did, particularly secant and tangent, and there's a relationship there that we can do some similar relationship or similar types of problems with secant and tangent. So before I go any further, however, I would like to derive the integral of tangent and the integral of secant for you. So let's go ahead and find the integral of tangent of x dx. And I'm going to do that by saying, oh, that is the integral of sine of x versus cosine of x dx. So far, so good. And then I can do a nice u substitution. U equals cosine of x, so that du equals negative sine of x dx. Negative du equals sine of x dx. So there's my du. So that becomes the integral of du over u, which is ln of u plus c, which is ln of cosine of x plus c, but I forgot something important. I'm actually kind of glad I did. Because remember, that negative in front can become the power on the cosine. Because that negative 1 power makes cosine in the denominator, which gives you the secant. And that's your integral for tan. And likewise,